Financial Maths, 2015 Paper 1, Question 6. So here we have Donna is arranging a loan and is examining two different repayment options. Bank A is going to charge him a monthly interest rate of 0.35%, and we have to find correct to three significant figures the annual percentage rate that's equivalent to the monthly rate of 0.35%. So this was a bit unusual because normally we're trying to convert the APR to a monthly. So whenever we're changing our rate, what we always do is we write down what is P equal to, what's F equal to, what's I, and what's T. And we use F is equal to P times 1 plus I to the power of T. So here we're trying to change from the monthly to yearly as opposed to our usual yearly to monthly. So P is always going to be 100%, so the original amount, in other words 1. And F is normally 100% plus the future interest rate. But we don't know what that's going to be this time. We're trying to find it. And then I we're given is 0.35%. So of course we have to write that as a decimal, which is 0.0035. And then our time, well, there's 12 months in a year. So if we write down F is equal to 1 times 1 plus 0.0035, and we're raising that to the power of 12, then that gives us F is equal to 1.042818,007. But of course, F is always 100% plus the interest rate. So therefore, what that means then is if I take away the 100%, in other words, I take away 1, that leaves me with I is equal to 0.042818,007. In other words, our APR is equal to 4.28%, because we have to get that correct to three significant figures. Okay, so part 2 then says, well, Bank B is going to charge him a rate that's equivalent to an APR of 4.5%, and we have to find correct to three significant figures the monthly interest rate that is equivalent to this APR. So again, we're changing the rate. And this time we're doing our usual of yearly to monthly. So again, we'll say P is 100%. F is going to be the 100% plus this APR of 4.5%. So in other words, that's going to be 1.045 as a decimal. I is what we are looking for. And then our T again is 12 months in a year. So again, if I just go to the left this time here, F is equal to P times 1 plus I to the power of T for changing our rate. And if we sub in our values, we have 1.045 is equal to 1 times 1 plus I to the power of 12. So we need to get I on its own here. So I'm just going to get the 12th root of both sides. And if I get I on its own, I have the 12th root, 1.045 minus 1, which then gives me I is equal to 0.003674,809. Sorry, but of course we want to correct to three significant figures, and we're looking for the rate. So remember, the rate is always the percentage, whereas I is always the decimal. So therefore we say our monthly rate, if I multiply that by 100 and correct to three significant figures, then I get 0.367%. Okay, so we had 10 marks going for that, and it was a 10C. So therefore that's 0, 4, 8 and 10. That's how they break down the marks for that A part. Okay, so B. So in B we said Donna has borrowed 80,000. Okay, so that's a loan. And it's a monthly interest rate of 0.35%. And it's a fixed term loan. And the loan has to be repaid in equal monthly repayments over 10 years. The first repayment is due 1 month after the loan is issued. And we have to calculate, correct to the nearest euro, the amount of each monthly repayment. So because this is a loan and its first repayment is due 1 month after the loan is issued, that means that we can use the amortization formula. Now, if we don't use the amortization formula, that means we would set up a geometric series where our first repayment is due at the end of the month, which means that would have to be discounted back. So that would start as A over 1.0035 to the power of 1, and then we'd get our geometric sum. But of course, if we can use the amortization formula, it's always a lot quicker. So we write down what information do we know? Well, we know that P is equal to 80,000 euro. We have a monthly interest rate of 0.35%. So we need to write that as a decimal. So it's going to be 0.0035. And that's monthly. And our repayments are monthly. So I don't need to change my rates here. And then the T is the time. So it's over 10 years. But again, we have to make sure that we're matching our time to our rate. So that means, of course, my 10 years have to be changed to months. So if I multiply that by 12, because it's 12 months in a year, I end up with 120 months. So if we go to page 31 in our maths tables, we can see our amortization formula here at the top is given by A is equal to P times I times 1 plus I to the power of T, all over 1 plus I to the power of T minus 1. So simply subbing in our values then, we can get our monthly amount. So we have 80,000 times I, which is 0.0035, times 1 plus I, which is 1.0035 to the time, which is 120 months, all over 1 plus I, so that's going to be 1.0035 to the power of 120 minus 1. So again, be very careful when you're subbing this into your calculator, making sure you're using brackets. That gives us 817.587002. And of course, we want to correct to the nearest euro. So that means that's going to round to 818. So that's 15C. So that was broken down into 0 marks, 5 marks, 10 marks, or 15 marks. And of course we would lose 1 mark if we don't have it correct to the nearest euro. So just as a note, if we had done it as a geometric series, then we would have had 18,000 is the sum of the discounted amounts of the future payments. So in other words, we'd have to discount back each repayment by a month each time. So the first one would have earned interest, so we would discount it back by 1 month. The second one would have been discounted back 2 months, all the way down to the last repayment, which would have to be discounted back 120 months. And then we would set that up as a geometric sum. And we would solve by getting our sum to end terms.